Hello, this is question 4 from Cambridge International Education winter exams from 2019. It's paper 1-2. You can find a link in the description below that will give you an image of this question. I recommend you try the question first before you're looking at any solution. And this question will involve geometry and trigonometry. I've done my best to draw it on the board, the information they give us. We have a circle with two tangents. So these are tangents. First thing that should tell us is we have a right angle, and we have a right angle here. So they are tangents, and they shade in this region outside. There's two parts. Part 1 asks us the perimeter of the shaded region, and part 2, they give us some of the numbers. They give us R and the angle, and they ask us to find the area of the shaded region. They also tell us that this 2 theta here is in radians. So that's important. Make sure your calculator is set to radians. Other than that, doesn't matter too much. Just remember a triangle is made up of pi degrees, not 180 degrees when we're in radians. A circle is 2 pi, not 360. Okay, so let's start with the first one here. Perimeter of the shaded region. So really I need to get the length of this part of the circle, the length of this line, and the length of this line here. The circle first is quite easy. There is a formula for it, but I'll just use the formula for a whole circle. The perimeter of a whole circle is 2 pi r. So how much of the circle do we have? We have just this part of it. We actually just have 2 theta out of 2 pi of the circle. So that's the whole circle. We have 2 theta of the circle. So we'll just multiply these together. 2 pi r multiplied by this proportion. Maybe this is a half, maybe it's a quarter, but this proportion of the circle. And it works out quite nicely. 2 pi divides the 2 pi. So this perimeter of just this section here, is equal to 2 r theta. So now what we need to find is the length of this line here. Now to do that, I'm going to use the information that you are allowed to know. I'll prove it now for you, but you don't have to prove it in the exam. I'm going to use the information that if I draw a line here, this splits it perfectly. This angle is equal to this angle. I'm going to use that piece of information. Now let me just prove why that is. Let me rub out this here, because we don't know that yet. Well, I do, you probably do, but let me just go ahead and prove it. You do know that this is a right angle. They tell us a tangent, so we're allowed to just say that's a right angle. We also know that this length is equal to this length. They're both r. They're both part of the radius. And we also know that this is equal to itself. So really what we have here is two triangles. Let me draw them again separately. I put it that way before, so I'll keep it that way. So we know this side equals this side. We know this side equals this side. And we know this angle equals this angle. These are similar triangles. They're actually concurrent triangles. They're identical. We know two sides are equal and one angle is equal. They're identical in every way. That means this angle here is equal to this angle here. That means since they add up to be 2 pi, that means they're both theta. And that's going to be enough for us. It also means this, whatever angle's here, is equal whatever angle's here. We're not going to use that, but yeah, another piece of information that this whole angle here is pi minus 2 theta. We don't need that, so I wouldn't worry too much about that. Let me just keep this here though, because we do need that each of these angles are the same. Actually, there's probably another way to go about it, but still, I'm going to use this one. So remember what I'm looking for. I'm looking for this length here. It's x. This length here is also x now. I now know they're both the same triangles. They're just mirror images of each other, really. So I need to find x here. I know I have 3 things. I have theta, I have r, and I have a right angle. And yeah, they want their answer in theta and r. So it's okay to use these. So we have 3 things. We can find another. So okay, what do we have? We have the angle, we have the opposite of the angle, and the adjacent of the angle. So that seems we will use tan. Tangent of theta is equal to the opposite over the adjacent. Let's multiply both sides by r. Or tan theta is equal to x. Okay, I think that's pretty much it. We have the length here. we have, well, let me go to this picture. We have this length, we have this length, we have this length. That's it, just add them all together. So let's see here. Let's see, P is equal to 2 or theta plus 2 of these. We have 2 of these, so 2 or tan theta. That's it, that's your answer. You could, if you want to be nice and make this a little neater, we could go theta plus tan theta. I would rather the answer look like that, but don't worry, I'll give full marks for both of these. So that's how we get the perimeter of this. Now I'll go ahead and rub this out and we'll do the part 2. Okay, for part 2 they actually give us some numbers. Or is equal to 5. Let me write these down so I don't have to keep looking. Or is equal to 5 and theta is equal to 1.2. Also, let me keep this information here. Or tangent theta. I'll keep that length there. Do I need that? Yeah, I am going to need that actually. Okay, so first of all, you can just put these numbers in now. I'm actually going to leave them. I'm going to leave them to the very end. I think it'll just end up dealing with more decimal places if I put them in now. Whereas if I leave it to the end of the question, it'll be a little neater and a little easier for me. It's okay, you can put them in right now if you want. Okay, but how do we answer this question? That's the important thing I'd like to teach. We want to get this red shaded area here. So there's no formula for that shape. There's just not a formula for that shape, but there is a formula for a triangle. We can get the area of a triangle. We can get the area of this triangle as well. We can add them together. That will that'll equal this shape. So we can get that shape here. This is the or tan theta shape here I'm looking at. We can then also, well, let me rub this out. I don't like having more than one equals here. We can get this shape. We have a formula. We also have a formula for this shape here, segment of a circle. Now again, I won't even use the formula. I'll just show you the whole circle, and we'll get the same fraction, 2 theta divided by 2 pi. So, but anyway, either way you do it, you can get the area of this shape, 2 triangles. The area of this shape, if we just take that away, that will equal the area of this shape. So while we don't have a formula for this one, we do have for each of these. So that's our job then. Really get the area of this, get the area of this. This one should be quite easy. So get the area of both of these, take them away, we'll have our answer. So let's backtrack here and let's try and get the area of these. First of all, the triangle. I've left this up here because it's pretty handy for us. The height, this is a perpendicular angle. So if maybe I'll redraw that for just a moment. If I flip that around, the top one here I've spun it all the way around. I've got the height here is or. This is now the lengthways here, or tan theta. Again, at this point you can put numbers in if you want. You'll just get awkward decimal places. I'll wait till the very end. Okay, so the area of this shape, because I just need 2 of them. The area of this shape is simply, let me get here, area is equal to half or multiplied by another or tan theta, and then we have 2 of these areas. So let's multiply that by 2. So the area of this shape is equal to 2 multiplied by half is 1. Or by or is or squared tan theta. So that shape is, let me draw it here. That's the area of that shape there. Now let's get the area of the segment of a circle. So the area of a circle, let's say area of a circle is pi or squared. But we don't want the whole circle. We just want 2 pi over 2 theta, 2 theta over 2 pi of the circle. Again, a very convenient number because it just divides in. In fact, you will find the formula for a segment is equal to theta or squared. So many of you would have just started with this. That's fine. So really all I need to do is take this one minus this one. So the final answer is the area is equal to r squared tan theta minus theta r squared, or let's make that a little neater, r squared tan theta minus theta. That would be the area, and they could ask you this in the exam. They could ask you find the area in terms of r and theta. So that would be the answer, except we know that r is 5. So this is equal to 25. We know that theta is 1.2. So this is tan 1.2 minus 1.2. Again, make sure you do this bit first there. The tan of this bit first. So we put that into a calculator and we get 34.303, and this says going on. Now it doesn't tell you how many decimal places to use, but you need to remember in the CIE exams, they always expect, if they don't ask you anything different, they always expect 3 significant figures. So that's 34.3. They'd be the 3 significant figures, and it's closest to 3, this one. So that's your final answer for the area there, 34.3. Yeah, I think that's both questions answered. If you have any follow-up questions for that, where did I get any of those formulas, something I did wrong, something you're not sure about, anything like that, put them in the comments below and I'll do my best to get back to you. Have a good day.